Okay, so we're looking at example number 4 now, and there's a couple of differences between this one and the last one, but most importantly is this bit here. We're now not given a one-tailed test. This is now going to become a two-tailed test because I've got, for my alternative hypothesis, probability that it is not equal to 0.25. So we're not making a guess either way. We're not going to say it's bigger or smaller than 0.25. We're just going to say it's going to be different to 0.25. Now, because it could be bigger or smaller, that means we end up with a two-tailed test. And a significant thing about that is that what I've got to do is say if the level of significance is 2%, but I'm now splitting that in two ways, then we're going to have 1% either way. So you half the level of significance in each direction if it's a two-tailed test. If it's a one-tailed test, you just take that percentage. For a two-tailed test, we're now going to look at just 1% either side. The other big difference about the question is that the critical region that we're looking for is not just going to be less than 1% on each side, it's just saying as close to 1%. So if we've got something that's slightly over 1%, usually we would discount that and say, well, it's not in the critical region. But because this one's just saying as close to 1% as we can go a little bit over if it's closer than the value that's slightly under. Now, what this means is that basically I'm looking for one tail where the probability is going to be less than 0.25 and one tail where the probability is going to be more than 0.25. And remember what I said in example number 3 about the direction of the inequality sign. So I need to split my work in half, and I'm going to be working over here looking at less than or equal to values for x, and over here I'm going to be working on greater than or equal to values of x for the second tail. So we follow the direction of the inequality and what we are looking for, and when I work these values down, I'm then going to choose the critical region will be the probability, well the value that gives me a probability as close to 1% as possible, as close to 0.01. So let's have a look at the lower tail first. I'm going to chuck a few figures in here. For a 1% is pretty small, so we'll start off, it is 40 numbers, so I'll start off fairly small. If I start at 1, 2, 3, 4, 5 and go up to maybe 6. N is now 40. The probability is the null hypothesis. Remember, this is what we are going to assume it's going to be. So 0.25. And it gives me some numbers in my list. Whoops. So it's going to give me, for less than or equal to 1, 0.00014. Okay, so that's pretty small. Less than or equal to 2, 0.001. Again, it's a bit small. And then 0.0046. Less than or equal to 4, 0.016, and less than or equal to 5, 0.0432. Now remember, usually we'd say, okay, it's got to be the first value that's less than 1%. So the first value is less than 1% is here. However, because this question just asked me to get as close to 1% as possible, it could be this one. So we've just got to see which one is closer to 0.01, and actually is going to be this one anyway. Okay, so my first part of the critical region is x is less than or equal to 3. It's the closest one we've got to 0.01. They're obviously a little bit easier, the less than or equal to, because the values I'll get on my calculator I can use straight in. These ones for the greater than, bit harder, but now we're going to go up the top end. Now because it's only a quarter here, just roughly do like a bit of a calculation in your head to say, well, a quarter of 40 is 10. So that's what we're expecting. So maybe if we go a little bit above that, so maybe we'll start at say 15. So I'm going to go through and try some new values in here. So I'm going to go X is 15, 16, 17, 18, 19 and 20. I'm still keeping N is 40, P is 0.25, and I'll get my list here. So remember, these are greater than or equal to, so I'm just going to put the values I get first. So for 15, 0.9737, I'll just put them to save a bit of space. 0.9884, 17.9953, 18.9982, and I think we're going to be able to stop there. So now I've got less than or equal to 15, so because I need to go greater than or equal to, because we're looking at a greater than 0.25, this is going to be everything that's less than or equal to 15 subtracted from 1 is going to be giving me everything that's greater than or equal to 16. So 0.0263. Okay. And then greater than or equal to 17 is then going to be 1 minus the less than or equal to 16, so 0.0116. And greater than or equal to 18 is 1 minus this is 0.0047. Now both of these are either side of the 1%, and we're just now going to pick the value that's the closest to 1%. So usually, again, what we do, we'd usually not consider this one because actually it's greater than 1%, but because we're asking the questions just go as close as possible, we are going to in fact choose this one because it's actually pretty close. It's only 0.0016 off. This is 0.0053 off. So this one is going to be closest to 1% out of the two of them. So now my critical region is X is less than or equal to 3, or remember we can use that set notation, X is greater than or equal to 17. And then from there, the actual level of significance, we're now just going to add these two values together. So if I just work from the back, the actual level of significance is 1.62%. Okay, so we should be able to have a bit of a go at exercise 7b.